Hello everyone, in the previous video we have discussed about the theory of simultaneous equations. In this video we are going to implement that theory to solve some problems and increase our base knowledge about simultaneous equations. So because maths is all about solving problems, so the more problems you solve, the more expert you become in that topic or in that subject, right? And in this video, the question levels are categorized into 4 categories, starting with the easy level, then we have medium level, hard level, and extremely hard level. So I will walk you through with some of the problems, while also I will be giving you guys some of the problems as your homework. So yeah, nothing to wait for, let's get started. So this is our first question of easy level. It says solve the equation x plus y is equals to 10 and x minus y is equals to 2. So as you know, this is a set of simultaneous equation. So the solution, I'm going to do the solution now. So there are two methods, elimination or substitution. Now since the coefficient in both of the equations are like the same, the coefficient of y, this is plus 1 and this is minus 1. So if I just add these two equations using elimination, I can just cancel this y's without any effort, right? So the first equation is x plus y is equals to 10, and our second equation is x minus y is equals to 2. So basically what I'm doing here is that I'm adding equation 1 to equation 2. Okay. So for that, I will first be adding xx. Like in elimination, you add the terms vertically. So x plus x is 2x, and then plus y and minus y will cancel each other out, so plus 0, and 10 plus 2 is 12. So we got 2x is equals to 12. Now if I divide both sides with 2, we get x is equals to 6. Therefore, for x is equals to 6, now I'll be substituting this value of x in maybe equation 1. So if I substitute it in equation 1, initially equation 1 is x plus y is equals to 10. So if I substitute this value of x, that becomes 6 plus y is equals to 10. Therefore, y, if I subtract 6 from both sides of the equation, I get y is equals to 4. So we already got our answer. That is, the values of our variables x and y are 6 and 4. Let me check if the answer is correct. Yes, it's correct. And I prefer you guys to also try the problem before actually seeing my solution. It's gonna help you guys a lot. And then you guys can check your answers with my solution and see if you missed anything. Okay, so our next problem says find the values of a and b if in these two equations. These two are the equations in our simultaneous equation set. So first of all, yes, we can here also we can go for elimination, since this is first of all this is a linear equation, both of them are linear equation, and as you can see one of the coefficient of b is plus and in the other equation the coefficient of b is minus 1. So using elimination, just like before, I can cancel them out. Therefore, I will just be eliminating, let's say this is our equation 1, and this is our equation 2. So for elimination, I'll be maybe add equation 1 with equation 2. Equation 1 plus equation 2. Oops, why did I give this here? Anyways, equation 2. So in this elimination, our initial equation 1 is 2a plus b is equals to 8, and then our equation 2 is 3a minus b is equals to 7. Now I'll just be adding these two, so 2a plus 3a gives us 5a, and then plus b and minus b cancels each other out, so plus 0, and then 8 plus 7 is going to be 15. So so this is going to be 5a is equals to 15, and if I divide both sides with 15, we get a is equals to 3. So this is one of our values of our variables, and now we will solve for b. So for b, we will substitute this value of a in any of the two equations. Both of them will work. So for a is equals to 3, let's say we input this in our first equation. For a is equals to 3, 2a plus b is equals to 8. So 2 times 3 plus b is equals to 8. And I just substituted the value of a here. So 6 plus b is equals to 8. And then b is equals to 2. I subtracted 6 from both sides of the equation. So therefore we have got our answer, that is a. The values of our variables a and b are 3 and 2 respectively. Let me check the answer. Yeah, our one is correct. And I hope you guys were also able to solve this by your own and just like checked your answers with mine. Okay, next on, moving to our next question. Now this is a new topic. We haven't really discussed about it in our theory video, but actually it is very simple. So in simultaneous equations, we solve for x and y. Now in simultaneous equations, we have two equations, these two. Now I hope you guys are familiar with graphs. Like basically in a graph, you have two lines. So say this is our y positive, like this is our y-axis, and this is our x-axis. Here we have all the positive x values, here we have all the negative x values, here we have all the positive y values, and here we have all the negative y values. Now can you see like some similarity? Like in simultaneous equations, we are finding the values of our variables x and y. Now let's say the value of x and y from our previous equation, let's say, let me go up, it was 6 and 4. So let's say it was 6 and 4. So we can easily plot this in our graph, right? So first of all, the value of x is going to be 6. So maybe 6 is here, and then the value of y is going to be 4. So the point is this one, 6, 4. This is how we plot our solution of simultaneous equation variables in our graph. Now, what do we actually do with this? As you can see, these are functions. Y is equals to x plus 5 is a function, and then y is equals to minus 2x plus 11 is another function. Now, why am I calling this a function? Because for every x value, you have a corresponding y value. So let's say x is equals to 1, if I give, that means y is going to be 1 plus 5, which is 6. So we are getting x and y as 1 and 6. Now in that way, if we, for different x values, we are going to get different y values. So in that way, let's say we have, these are example graphs. I didn't calculate anything, just I'm writing, like I made two graphs just myself. Okay, so these two graphs have no relation with these two functions. Okay, so what I'm trying to show here is that, let's say this is the graph of y is equals to x plus 5, and this is the graph of y is equals to minus 2x plus 11. Now as you can see, our point 6, 4 lies in a point where the two graphs intersect, and yet that's all. Like the solution of two simultaneous equations is their intersection point. That's it. That's why simultaneous equations are very important. When you learn graph for your maths D or admaths, you will see that we use simultaneous equations to find the intersection point of two graphs. This is one of the most important use cases of simultaneous equations. Anyways, coming back to our problem, we had y as x plus 5 and y as minus 2x plus 11. What we can do here is that, as you can see, the equations are already subjected with values of y, and we can say that y is equals to y, right? Obviously. So for y is equals to y, I will substitute the two values of y. So that is x plus 5 is equals to this one, our second y, that is minus 2x plus 11. So we will just normally solve it. That is x plus 3x is equals to 11 minus 5. And then 3x is equals to 11 minus 5 is going to be 6. And then if I divide both sides with 3, we get 6, x is equals to 6 by 3, which is equals to 2. So we have already found a value of one of our variables, and using this I will just be substituting this value of x in any of the equations. So for x is equals to 2, I prefer to substitute this value of x in equation 1 for simpler calculation. So y is equals to x plus 5, then y is equals to 2 plus 5, so y is equals to 7. So therefore our point of intersection is equals to our values of x and y, which are x is going to be 2 and y is going to be 7 respectively. So yeah, this is how you find the intersection point of two functions in using simultaneous equations. It is something very interesting, and it still fascinates me for mathematics. Anyways, now here are some problems that I'm giving you guys for homework, and to help you guys, I'm also giving you guys the answer so that you can check your solution with mine and see if you have any problems or not. And I hope you guys will be able to solve this, as we have already practiced 3 problems in this class, and you guys are going to do these 2 problems as your homework, or you can do it right now by just pausing the video and complete it. Okay, so for the solution of this question will be x and y, the values of x and y is going to be 2 and 3. Oh, okay, my Windows autocorrect. Okay, 2 and 3. And for this question, the values of x and y are going to be 2 and 3. All right. Now, by the way, this problem is similar to this one, so you can try it right now and check if you understood what I meant here. So in medium level, as you can see, we already upgraded our level, and now we are dealing with fractions in simultaneous equations. So in this problem, we just have to solve for x and y. Now our first equation is much simpler, that is, our second equation. Let's say this is our equation 2 and this is our equation 1. So here in equation 2, I want to subject the equation for x, so it will be 3 plus y. Now I've subjected the equation for x, and for this I am going to use substitution. So this is the subjected equation of x, and let's say this is the new equation 1. So now I'll be inserting equation 1, or the value of x, in our equation 2. So let's do this. So initially our equation 2 is x plus y by 3 is equals to 4. Now it is going to be, if I substitute the value of x here, that is going to be 3 plus y by 3 plus, oh oops, I made a mistake here. This is going to be 2, not 3. This y by, this is going to be 2 is equals to y by 3 is equals to 4. Now what I can do here is that LCM these 2 denominators, and the LCM of 2 and 3 is 6. So the first expression will be 3 times 3 plus y plus 2 times y divided by the LCM is equals to 4. Now it is going to be 9 plus 3y plus 2y by 6 is equals to 4. Now it will be 9 plus 5y, I added this 2, and then if I multiply both sides with 6, that gives us 6 times 4, that is 24. 9 plus 5y is equals to 24. Now here if I subtract 9 from both sides, that gives us 5y is equals to 15, and therefore if I divide both sides with 5, that leaves us with y is equals to 3. So as you can see, we have already found one of the values of our variables. Next we will find the value of x. So for y is equals to 3, we are going to find out the value of x. So as you can see, our equation 2 is very simple, so I'm going to use our equation 2 for this for simplicity. So x minus 3 is equals to 3, so obviously x is going to be 6. So therefore our answer is the values of x and y are 6 and 3 respectively. Anyways, we are done with it. Moving on to the next problem. In this problem, we got two simultaneous equations and we will have to find the values of our variable x and y. Now, in this case, we will have to first simplify these equations so that it's easier for us to solve it. So let's say this is our first equation. We got 2x minus 2 plus 3y is equals to 10. And then it is going to be 2x plus 3y, and if I add 2 to both sides, this 2 cancels out, and this is going to be 10 plus 2, that is going to be 12. And now for our second equation, which is x plus 2 y plus 1 is equals to 9, and here we just have to simplify it. So x plus 2y plus 2 is equals to 9, and then x plus 2y is equals to minus 7. Oh, sorry, 7. Now I think we can easily substitute, like make x the subject of this equation, as the coefficient of x is already positive 1. So to make x the subject of this equation, what we can do is that x is equals to 7 minus x is equals to 7 minus 2y. Now this is our subjected version of equation 1, and this is our new version of equation 2. So I'm calling this equation 1 and this is equation 2. So for this I will be using substitution. So in substitution, what I will be doing is that I will insert equation 1 in equation 2. So to do that, initially our equation 2 was 2x plus, it is 3y. 2x plus 3y is equals to 12. Now if I substitute x here, that is going to be 7 minus 2y plus 3y is equals to 12. That is going to be 14 minus 4y plus 3y is equals to 12, and then it is going to be 14. First of all, I will be evaluating the y's, so the coefficient is going to be minus y is equals to 12 minus 14 is equals to minus 2. So now if I multiply both sides of the equation with minus 1, we get y is equals to 2. And hence we found one of the values of our variable, and for our next variable we will just use for y is equals to 2. I want to insert it in our first equation as x is the subject of that equation. So 7 minus 2, and then the value of y is 2, so it is going to be 7 minus 2 times 2. Therefore the value of x is going to be 7 minus 4, and hence the value of x is 3. And therefore the solution of this equation, of this problem, is the values of the variables x and y are 3 and 2 respectively. I hope you guys were also able to solve this, and yeah, this is the answer if you want to check. Coming to our last equation in our medium section. Now for this equation you will also have to learn a concept if you don't know. So what is supplementary? Supplementary means that, okay, let me first draw an angle. Let's say this is a plane and we have an angle here. Now this is one angle and this is another. Let's say this is angle A and this is angle B. Now the basically what supplementary is, that is angle A and B are like supplementary. That means that angle A plus angle B is going to be 180. Let's say the value of angle A is 100, then we can find out the value of angle B. So if angle A is 100 and we will find the value of angle B, so B becomes 80. So that is basically what supplementary means. The two angles add up to make 180 degrees. And don't worry, we will cover them when we make videos on geometry. I like geometry, it's fun. Okay, anyways, so let's focus on our question. It says that if P is equals to 20 degree larger than twice Q, find both the angles. Now they said P will be 20 degree larger and it is a constant. So 20 degree is a constant here. So if we want to write the equation in terms of P is going to be something plus 20. So then it said that larger than twice Q. So we got our answer for something here. Is going to be P is going to be 2Q plus 20. And check it with the statement. It said that P is going to be larger than twice Q, 20 degree larger than twice Q. So this is 2Q plus 20. I hope you guys were able to understand that. And as you know that as they are complementary angles, P and my Windows autocorrect is like very weird. Okay, so P and Q is going to be 180 degrees. So these are the two equations we got here for which we are going to simultaneously solve. Now I think it's better if I use substitution. So let's say this is our equation 1 and this is our equation 2. So what I want to do is that I want to insert equation 1 in our equation 2. So it is going to be, initially our equation 2 was P plus, so it is going to be P plus Q is equals to 180 degrees. And now we got P here. So we got the value of P. So we have 2Q plus, okay, wait, let me turn off auto geometry correct because it's like acting very weird right now. Anyways, I don't think so we are going to face any more problems like that anymore. Okay, coming back to our problem. So what I'm going to do right now is that I'm going to substitute the value of P, that is going to be 2Q plus 20 plus Q is equals to 180 degrees. So it is going to be 3Q plus 20 is equals to 180 degrees. Now if I subtract 20 from both the sides, 3Q is going to be 160 degrees. Now if we divide 60 degree with 3, we get, I think they don't really like fully divide, so 360 by 3, which is going to be, so let us first divide 160 with 3. So 3 5s are minus 15, that is 10. 3 3s are 9, so minus 9, that is 1. And then this is a reoccurring decimal, so we have 53.33 degrees. So the value of Q we have found, that is 53.33 degrees. And now for this value of Q we can easily find the value of P. So for Q is equals to 53.33 degrees, we can get the value of P. So P is going to be 2 times Q, that is 53.33 plus 20. So 2 times 53 is going to be 106.66 plus 20, that is going to be 126.66 degrees. Hence the value of our P and Q is going to be, let's say this is answer, P and Q is going to be, P is 126.66 degrees, don't forget the degree by the way, and then Q is 53.33 degrees. Now you can also check your answer like this. So as you know, the question says that P and Q are supplementary angles. So it is true that P and Q will be 180 degree. So if we substitute the value of our P and Q, so P is 26.66. Okay, wait. And then our Q is 53.33, which gives us 5 plus 2, okay, 179.99, which is approximately 180 degrees. I hope you guys got what I'm trying to say. Now moving on to the homework I'm going to give you guys from the medium level. The first one is this one, whose answer is going to be 20 by 9 and 22 by 9. And then this one's answer is going to be, let me find it out. Oh yeah, it's the values of x and y are 2 and 1. This is the value of x and this is the value of y. So I hope you guys were able to follow till this far, and I also hope that you guys like actually complete this homeworks and get the actual right answers. So to keep this video short, I did a total of 10 problems right now, and we are going to start the hard and extremely hard levels. So that's all for today. I hope this video was helpful and these problems helped you know more about our simultaneous equations, and in the next video I will be completing all the hard and extremely hard problems for you guys. So thanks for watching. I hope this video was helpful. Please like and subscribe this video. Thanks.